Hello everyone. Now, I will make a brief introduction to point cloud automata. Point cloud automata is a one-step software for automated intelligent point cloud post-processing. This lecture is composed of 6 parts. In the first part, I will introduce the LiDAR. LiDAR stands for light detection and ranging. It is a surveying technique, scans a surface using laser light and returns a densely populated 3D point cloud. LiDAR point clouds have been used in many applications, and point cloud is now a very common type of spatial data. What is point cloud? Point cloud data refers to a set of vertices in a three-dimensional coordinate system. These vertices are usually defined by x, y, z coordinates, and typically are intended to be representative of the external surface of an object. Where is the point cloud from? ALS, UVA LiDAR, mobile LiDAR can yield different point clouds with different characters. Why is the LiDAR so popular in recent years? This attributes to that LiDAR has 3 advantages. First, LiDAR is able to penetrate tree canopy openings in the forested areas. Second, LiDAR is able to directly get the high accuracy 3D point cloud with a fast speed. Third, LiDAR is able to day and night operation and not sensitive to weather. What can the point cloud do? At present, LiDAR has many industrial applications, such as terrain mapping, forest resources inventory, power line inspection, profile mapping, urban 3D reconstruction, high precision map for automatic driving, etc. In the second part, I will talk about some drawbacks of current data processing. First, most of the users are puzzled by the professional terminology. For example, filtering means ground classification in the field of LiDAR, but it means noise removal in many other fields. Second, the operation of the software is complex. If a user wants to finish some task, many independent tools are needed, and each tool has its own location. Some users may omit some step, which leads to failure. Third, software usage relies on experiences. A user should set up many parameters, but it is hard to fix a suitable value for each parameter. Fourth, repetitive input and output are designed to finish a task, which leads to low efficiency. Fifth, there may be many errors in the results, and it will exhaust many labors to deal with the errors. 6. It is very hard to process massive data. No matter the visualization, nor the automatic processing, small data is necessary. Now, the UVA LiDAR data volume is very huge, which is a great challenge. In the third part, I will introduce point cloud automata. This software of point cloud automata, short as PCA, is a one-step software for automated intelligent point cloud post-processing and analysis. Point cloud automata includes 2 main software now. One is PCA Terrain, and the second is PCA Forestry. PCA Terrain was released in April 2021, and it is our focus in this lecture. PCA Terrain focuses on the terrain mapping, and it also has some functions for trees extraction, building extraction, power line reconstruction, and so on. PCA Terrain has some highlights. First, advanced algorithms are from our fundamental research. internationally, introduced the details of the classic progressive thin densification filtering algorithm for the first time. Related articles were published in the internationally renowned academic journal, ISPER's Journal of Photogrammetry Remote Sensing. Internationally, proposed and realized a one-step, implicit parameter filtering algorithm on generalized point cloud, which promoted the low-entry application of UAV LiDAR technology. Internationally, supported efficient filtering and classification of a single loss point cloud file containing up to maximum points. Internationally, proposed the point cloud filtering strategy of steep cliff body. These are our papers, patents, and awards. Second, it is an independent system. It can be run on Windows 7, Windows 10, Windows 11, and Windows Server 2015, 64-bit. Third, it is world's leading one-step intelligent data processing software. It has more than 50 one-step tools for ground classification, point cloud classification, tree segmentation, etc. Fourth, it has innovative core algorithms, different to the point-based algorithms. Multi-primitive including point, multi-level object, key point, are simultaneously used in our algorithms. Fifth, it is very fast for large data attribute to parallel computing and steam computing. Sixth, it supports massive point cloud data visualization and processing. Seventh, it supports 9 different types of point clouds such as LiDAR point cloud, dense image matching point cloud, sonar point cloud, etc. Eighth, we enhance point cloud visualization by special property like 3D perception. In the forepart, I will introduce main functions. This is the main interface of our software. PCA Terrain is divided into 5 parts, based on the function similarity. First, about data visualization. Summa profile window can be generated from the main window. Moreover, the point cloud can be displayed by elevation, RGB, intensity, 3D perception, and so on. Finally, animation tool helps us to record video about the point cloud. Second, about the data preparation. There are many tools, such as tilling, coordinates transformation, merge, preparing the point clouds for the one-step operations. Third, the one-step processing is our prominent highlight. There are more than 50 one-step tools for filtering, point cloud classification, single tree segmentation and information extraction, etc. Fourth, many manual addition tools are designed to modify the errors. Finally, our software can output 30 kinds of results, such as DEM, DSM, contours, sections, 3D models of trees, volume report, building outlines, etc. In the 5th part, I will introduce some typical solutions. PCA Terrain supplies whole solutions for different types of industrial applications. First, in the field of terrain mapping, 3 stages, including divide-conquer output, are proposed to generate outcomes, such as DEM and contours from the point clouds. Moreover, once the ground points are precisely separated from the non-ground points, we can get sections for the roads and rivers. And we can also calculate the volumes of mines. Similarly, in the field of forestry resources inventory, Individual tree segmentation and information extraction can be performed from both airborne LiDAR data and terrestrial LiDAR data. Finally, the 3D reconstruction of the conductors can be realized in our PCA Terrain. At last part, I will see 3 practical cases. In the first case, the one-step ground classification is performed on 2 hilly areas. From the final DEM, we can see that our software can preserve the ground points around hilltops, ridges, break lines, as many as possible, while it can remove the non-ground points. Similar result can be obtained in the second case. Erased fields and break lines are well preserved. In the third case, the forestry point cloud is well classified, and single trees are detected. The 3D tree models are superposed on the DEM, and a virtual forest is fast constructed. Finally, we can count the total number of trees. We can know the position, height of each tree. That's all. Thank you for your patience.